So just out of interest, who works at a company that's using microservices? Just, okay. And like, or at a company who's thinking about it? I think that's pretty much, it's the vast majority of people, right? Does anyone think it's like a complete waste of time and they love their monolith? Though interestingly, as I'm going to mention, I mean, you know, the monolith is not an anti-pattern. It's actually an appropriate architecture in the right situation. Anyhow, so welcome to my talk about the microservice architecture. And, you know, really kind of the goal of the talk is just to explain what, you know, in a more precise way, what I mean by the microservice architecture. Kind of actually going to describe it as an architectural style, actually explain what an architectural style is, and then sort of talk about why the microservice architecture, or specifically an architecture in general, matters. But before I talk about that, first a little bit about me. So, you know, if you don't know me, I got my start in programming like 20-odd years ago, almost 30 years ago, building Lisp systems, compilers, runtimes, all that kind of stuff. You know, I eventually programmed in Java. 10 years ago, my book, Pojo in Action, came out. That was all about Spring and Hibernate. Started tinkering with Amazon EC2 back when Amazon was best known as a bookstore, before they started doing this cloud thing. Got super excited about that, ended up creating Cloud Foundry, or the original version of Cloud Foundry that was a PaaS for deploying Java applications on EC2. That got acquired by SpringSource, which then got acquired by VMware back in 2009. Was part of that for some number of years. And these days, I'm pretty much focused on the microservice architecture. I left sort of the corporate world behind, and I work for myself, doing consulting and training around microservices, helping companies get started going down that path. Also working on a startup, creating a platform to simplify the development of business applications, which are sort of transactional in nature, as opposed to sort of consumer-facing websites, which are primarily read-only. That's all about event-driven architecture. That's a whole other fascinating topic. Working on a book that's available in Meep about sort of microservice architecture. And then if you want to know more after this talk, if you go to learnmicroservices.io, that points to a whole bunch of resources, including example code, articles, presentations, and so on. So that's me. So let's get on with the talk. So I'm going to begin with a brief refresher on what we mean by software architecture. I think a lot of the time when we talk about architecture, it's looking at the latest cool thing from Facebook, you know, Uber, Google, etc., and going, wow, that's really cool, right? And it's operating at massive scale and sort of getting excited about it. But, you know, architecture actually has a much deeper meaning than that. And then once I've sort of defined what I mean by architecture and why it matters, I'm going to talk about the monolithic architecture, the benefits and drawbacks of that, talk about the microservice architecture and its benefits. And then I'm going to, at the end of the talk, I'm going to sort of talk about the drawbacks of the microservice architecture, how it's not actually a silver bullet, and then describe many of the issues that you're going to face when trying to use microservices. And I'm going to describe this pattern language that I've created, and those are patterns that can guide you in using the microservice architecture effectively. And all of that in the next 45 minutes. Okay, so let's talk about software architecture. You know, it's a term we use a lot. And what I sort of feel is that if I went back in time, say 20 years, you know, we talked about architecture in maybe a different way than did now, it's sort of, to some extent, kind of faded away as something that we explicitly discuss or treat as a discipline. But this slide has the classic definition of what we mean by software architecture, and it's a set of structures that we need in order to reason about a system. So we've got to kind of describe the architecture of our system so that we can think about it, make decisions, and so on. And more concretely what that is, it's a set of software elements and relations. And those elements and relations or relationships have properties, which might just be a name, but it could be sort of a deeper meaning than that. So in other words, it's kind of like architecture is a set of elements, a set of relations, and the properties of both of those. Those are all kind of abstract kind of definitions, or you can just think of it as a bunch of boxes and lines, right? Which is, I mean, the boxes are elements, the lines are the relationships between them. But it's sort of deeper than that in many ways. So, for instance, you think about the architecture of this building. In order to properly describe the architecture, you actually have to look at it from multiple perspectives. So from one aspect, there's the presumably concrete and steel, whatever this building is made of, right? There's the structural aspects of it. And that's great if you're a structural engineer, but if you're an electrician, you're not interested in concrete and steel. You're interested in the electrical architecture of the building. And likewise, if you're into the plumbing, there's that architectural aspect where all those tubes and pipes goes, right? And then there's sort of the mechanical side of it and so on. So in other words, in order to properly describe the architecture of this building, you have to look at it from multiple perspectives, of different stakeholders. Or in other words, you've got to construct multiple blueprints, which is blueprint drawing boxes and lines with specific meanings, and each one of those blueprints shows the architecture from a different perspective. And each perspective or a view is just that. It's elements, relations, and properties. And the architecture of software, turns out, is kind of similar in that respect. So in order to properly describe the architecture of a software system, you need multiple views. And the classic kind of view model for software architecture is this 4+1 view. Just out of interest, who here has heard of it before? I don't know if you have to have gray hair in order to have heard of it, but, but it's sort of this, I think it's from like 20 odd years ago, and it was talked about, and then I feel like it faded away, and in a way, I only started thinking about it like within the past year. But basically, it's saying in order to properly describe the architecture of a software system, you need 4 views: the logical, implementation, process, and deployment view. And then the +1 are these scenarios which show how the elements within a particular view collaborate in order to handle a request. So it's just looking at it from different perspectives and then using these scenarios to show how each components or elements within each view collaborate. So if we look at the logical view, well, we program in, for the most part, in an object-oriented language, right? And so the logical view is what we as software developers create, namely classes or the equivalent. And then those classes are organized into packages. And so the elements in this view are classes and packages, and the relations between those elements are the usual kinds of relationships like inheritance, association, dependency, and so on. So that's the logical view. That's sort of describing one particular aspect of the software. And then there's the implementation view, which is basically describing what comes out of the build system. So in Java, our classes get compiled down into jar files. And then those jar files get assembled into some form of executable or deployable unit. So that could be an executable jar, or it could be a WAR file. And And in other languages, you basically have equivalent sort of notions of module, which is this kind of packaging of something, and then a component that is the executable or deployable something. So I don't know, in this Windows world, DLLs, right, and assemblies and stuff. It's been a while since I've looked at that well. But yeah, it's a fairly universal concept. So we've gone from, our programmer-created artifacts, classes, packages, into these compiled or packaged units, and then most importantly, an executable component. And then you have the process view, which is sort of the runtime view of all of that, which is those components. So our, classes get turned into these executable or deployable components that are basically running as processes. So in this example, there's like various tomcats talking to a MySQL master, which then has a MySQL slave. And then the relationships within this view represent inter-process communication. And then you've got the deployment view, which are those processes running on nodes or machines. So used to be physical machines. These days it's likely to be a virtual machine, or they could represent containers. And then the relationships between them represent some form of networking. So those are the four views. And then you have the scenarios that, for a given view, show how the elements within that view collaborate to handle a request. So in this example I have here, right, that's a sequence diagram, at least I guess from the logical view, showing how my classes collaborate to handle that one request. But you could have a similar diagram showing the flow between processes or the flow between machines. So like when I go to a client and I say, what's your architecture? I'm so hoping that they're presented in this form. And if they're struggling with that, then we actually figure out how to take their ideas, which might be a little woolly, and translate them into a set of views with a set of scenarios. So that's sort of kind of the idea behind architecture and how you can describe it. And then there's this concept of an architectural style, which once again has kind of is analogous with the physical world, where buildings are constructed in various architectural styles, right? Like Victorian, Georgian, Art Deco. Software kind of has a similar concept of an architectural style that basically says, yeah, you've got these elements and relations within a particular view. Here they're referred to as components and connectors, but because it's kind of different authors, different book, but sort of one-to-one mapping there. And then the architectural style constrains the set of elements and the relationships that you can have, and kind of defines how the various pieces put together. So the most classic example of an architectural style is a layered architecture, which says, yeah, we've got a bunch of elements, but we're going to organize them into layers. Each layer has a well-defined set of responsibilities. It's not just a random collection of components that we just try and organize into a layer. It has to have be meaningful. And then there's a really important constraint in terms of the dependencies. So if you've got strict layering, a layer can only depend on the layer immediately below it, or if you've got relaxed layering, it can depend on any of the layers below it. And that's kind of that's a great example of an architectural style. So, we've got kind of a definition of architecture. We've got 4+1 view as a way of describing your architecture, plus this concept of architectural style. And then it's like, well, who cares? Why does this matter? And what's interesting is, well, if you look at the requirements for an application, there's really two kinds. There's the functional requirements, what it does, which is usually described by use cases and stories. And yeah, you can implement those requirements often with almost any architecture, even a big ball of mud. In fact, many software systems have degenerated into big balls of mud, and we muddle along and we keep implementing new requirements. But it's not much fun, and that kind of leads to the non-functional requirements, or the ilities, or these software quality attributes, and those are where architecture matters. So if you've got particular goals, particular non-functional requirements around, performance or scalability or maintainability, that's when you have to think hard about the appropriate architecture for your system. So if you go to Wikipedia and look up sort of non-functional requirements, there's this big long list of ilities. Obviously like reliability, scalability, securability, just made that one up, security, clearly not paid attention to at Equifax, right? So there's all these different attributes, software quality attributes or ilities. But kind of the ones I'm focused on in the context of the microservice architecture are really the first three, namely maintainability, testability, and deployability. And those are really interesting because it's those attributes of your software architecture that actually determine your development velocity. If those attributes are good, then you can develop and you can deliver your software quickly. If they're bad, development will be slow and painful. And this matters today, for the usual reasons, right? Like businesses need to innovate faster, which means that we as developers need to deliver better software faster. So we've just got to, we basically have to do a much better job at delivering features. And more concretely, that kind of boils down to sort of two attributes, right? Like reducing lead time, which is the time from when a developer commits their changes to those changes being deployed in production. Like today, it's sort of we're kind of shifting from delivering packaged software to building SaaS applications of some form, right? And in that context, you want to minimize the lead time from a commit to that change being into production, and you want to increase your deployment frequency. Years ago, you released every 6 months, right? In fact, some people still do. But when you look at the state of the art, it's actually releasing or deploying many times a day. Right, there's some statistic where Amazon.com are deploying into production every 11.6 seconds. And your ability to do that is really dictated by the architecture of your system. So I like to think of modern software architecture, or your ability to develop sort of software in a modern way, is really a combination of three things, right? One is process, and the state of the art for that is continuous delivery and continuous deployment. You've got to have the right organization in place in order to do that, right? Which turns out to be sort of small autonomous teams, the so-called two pizza teams. And then you've got to have the right architecture that really enables those other two things. And that's kind of where this whole monolithic versus microservice architecture comes into play. So if we look at the monolithic architecture, it works something like this, where from a logical perspective, so the logical view of our software is likely to be layered and modular. So it's going to be, so in this case, we've got a presentation layer. The back end is comprised of various packages or modules. But then, what do? We go and package everything up as a single executable or deployable component. And that, this is sort of the Java perspective of the world, right? But it's just this notion that we're just building the application. And the application is just one WAR file or one executable. over the years, I've sort of worked for numerous startups, and it was like one startup equals one WAR file, right? And that would have user-facing functionality, it would have administrative functionality, because, well, we were just building the application. And, there's interesting consequences of that. So a sort of precise definition of the monolithic architecture is that it's an architectural style in the implementation view that structures the application as a single executable component. There is a variation of this where you have some services, but they're tightly coupled through the database, and they basically have to be deployed as a single unit. So it's sort of kind of like a distributed monolith. But that's sort of like, in a sense, the worst of both worlds. So that's the idea, just this, this single tightly coupled thing that has to be deployed as a unit. But as I mentioned at the beginning, this is not an anti-pattern, because when you have small monolithic applications, they tend to be easy to maintain, test, and deploy, right? Like, on day one of your application, it's really easy to make changes and push it into production. But the trouble that you run into is that, if you have a successful application, people keep using it, and they keep wanting more features, and so it tends to grow. So you might start off small, and small application, smallish team, but over time, the application is getting bigger and bigger and bigger. And this could be over some number of years. It just keeps growing, and the development team, can keep growing as well because you've got more money and because you're successful. And you might try and split up into multiple sub-teams where each team is focused on a particular functional area. Especially if you've got hundreds of developers, you can't really have a daily stand-up with a team that big, right? So you want to have small teams, 6 to 8, 10 people, because that's much more manageable. But eventually, your application just is growing and growing and growing. And eventually, you just end up with this sort of monstrous application, possibly, comprised of millions of lines of code. And we end up in this situation where any ability to develop or deploy in an agile fashion is really, really difficult. It just takes longer and longer to get changes deployed. Or you make a change to fix a bug, and that has unintended consequences and creates more bugs. So you're sort of in this world where things are very unmaintainable. And so this is what I call monolithic hell. And then not only that, you've probably, your technology stack is increasingly obsolete, because at the start of the development of your application, you made a bunch of reasonable choices, but 5 years later, technology has moved on for the better, usually. And so because you've got this large code base, it's really difficult to rewrite it to use a more modern technology. I mean, I've talked with clients that can't even upgrade to the latest version of the Spring framework, even though Spring is very backwards compatible, because they're using like an old version of, say, an ORM library, and the new version of Spring needs the newer version, and so you just get stuck in the past. So you're sort of in this very painful place, and so your ilities are bad, right? It's difficult to maintain. Testing is difficult and time-consuming, and deployment is just this painful, risky process. So, but it's important to stress, in the right situation, the monolith is a good choice. So that's when you want to but when you are in monolithic hell, that's when you want to start looking at the microservice architecture. And that's another architectural style that structures, in the implementation view, that says, well, we're going to have a bunch of services, or executable components that are loosely coupled, so they can be developed and tested and deployed independently of one another. and they're organized around business capabilities, so business functions. So you have a team that's working on a business functional capability, delivering a service that performs that function, and it's recognizable to a business person. So, imagine like an online store. You can take orders, you manage inventory, you manage deliveries. Those are the business capabilities, and you define services corresponding to each one of them. So that's kind of the idea, is to analyze your application problem domain, identify these business capabilities. So it's like, in a sense, you're defining your business architecture and then defining a technical architecture that mirrors it. And that to me is the essence of the microservice architecture. And what's interesting is that none of this is really, I haven't said anything about size, right? And this is sort of an interesting problem with the term microservice, is that it makes you think that it needs to be small. Like in the early days, people would say, oh, it should be 100 lines of code or 2 weeks worth of work, right? But in reality, size is this secondary consideration. A service should implement some meaningful business functionality. It should be capable of being developed and ideally deployed and operated by a small team with minimal lead time and a high deployment frequency as well. And provided you meet those kind of requirements, then you have, in my mind, a good service. So, size in terms of lines of code or development effort is certainly lines of code, that's a useless metric. And it's really to be supporting a small team is the key. To develop efficiently or deliver efficiently is the key attribute. So I think of it in these terms, right? So to me, microservices is a shorthand for the microservice architecture, which is a form of application architecture. So given this, it's like, I don't really think of there being this notion of a standalone microservice is not a particularly useful thing, right? Services come as a system and not as standalone entities. What was it? DDD Borat made some tweet about one of my talks where it was like, they're like camels, they come in herds. But Rich. So given that, right, when you think about the microservice architecture, you're going to have an architecture that looks like this. So you've got a bunch of services. Each service has its own private data. That's essential to ensure loose coupling, even though that creates some really interesting challenges around maintaining data consistency or querying. You can functionally decompose your web application as well. So, one web application for browsing and searching products, another web application for the product detail page, another one for checkout, and so on. And then if you need to expose some form of API to the outside world, you would have an API gateway that sort of acts as a facade, exposes an API to the outside world, and hides the actual services, individual services. And that could be used by a mobile device or native app running on a mobile device or JavaScript running in the browser. So we've kind of got a much more complicated architecture. We've gone from a set of load-balanced Tomcat instances to, gosh, there's lots of boxes and lines on this diagram. But that kind of hints at the complexity of the microservice architecture. But it ends up being a way of delivering software quickly. So hopefully you have good maintainability, right? The individual services are small and easy to understand and change. They're small and easy to test, and then they can be deployed independently as well. And really, the whole point of this architecture is really to enable the continuous delivery and deployment of large applications. So I like to think of it as the microservice architecture gives you the testability and the deployability that continuous delivery needs. And also it promotes the notion of having autonomous teams. Because even if you have a small set of small teams, if they all have to contribute to the same code base, they can't deploy independently. You've got that whole release train notion and a lot of communication and coordination between the teams. Whereas with the microservice architecture, each team has their own service or set of services that they can develop, test, and deploy and scale independently of all of the other services. I mean, assume once you've established once you've agreed on APIs with other teams whose services that you need to communicate with, you can go your separate ways. And so this gets to the essence of why the microservice architecture is good. And then that leads you to this sort of being able to sort of achieve state-of-the-art development metrics where you can deploy many times a day. The lead time from committing a change to that change being pushed into production is hopefully less than an hour. So you're moving fast, but not only are you moving fast, but you're not breaking things because it supports automated testing. So when you push something into production, you can be pretty confident it's going to work, right? You're not going to have outages. And this is actually from the DevOps report. And it's got fascinating numbers in there. But it really, the huge contrast between like low-performing IT organizations, which are deploying once a month and breaking things, and high-performing IT organizations that are deploying many times a day and not breaking things, which is kind of that's sort of backwards in conventional thinking, right? But the microservice architecture is a key enabler of that. And then not only that, it actually enables you to evolve your technology stack as well. Because when you write a new service, at that point, you're free to pick whatever technology stack makes sense for the problem you're trying to solve. Or, you can pick the latest fashionable thing, right? Like Golang, because Google uses it, so it must be cool, right? And that's okay, because you can actually go and build a service in Golang, for instance. And then when you find out that it's really this sort of low-level language and you much prefer a high-level language like Java and I'll say C# to be nonpartisan, it's not a disaster because you've got a service, yeah, but you've only invested a relatively small amount of time and effort using that language, performing that experiment. You've learned something useful about the suitability of that language for your organization. And if you decide to rewrite it in something else, you just do it at some later point. It's not like you've spent 3 years building a massive system in some language only to find out you hate it, right? So it's great. It lets you experiment safely, fail safely, and just generally evolve your technology stack. So a lot of significant benefits. But as I mentioned at the beginning, the microservice architecture is not a silver bullet. So this is Fred Brooks. He wrote The Mythical Man Month, and I think that was back in 1975. And so it's actually worth reading because even though it's sort of like, 40 years old, nothing has changed really in software development. Really nothing. I mean, the sort of the language that he uses to describe things has changed, right? Like he talks about the corner office and secretaries and things, but it's things, that side of things has moved on because now we're all in cubes, right? Or open plan or whatever. But one of the things he said in a talk, like I think that was back in '85, was there are no silver bullets in software engineering. There's nothing that will give us like kind of this massive boost in productivity. A whole bunch of things you can do that will slow you down, but there's no magic silver bullets. Even though I think we in the software community are constantly looking for the latest silver bullet. But there are some significant drawbacks. I've already hinted at the fact that the microservice architecture is much more complex. And it's sort of complex in several different ways. So from a development perspective, you're building a distributed system, so you have to deal with inter-process communication, partial failure, the fact that your data is spread around multiple services, and how do you query it? How do you maintain data consistency? Good news is that there are solutions to all of these problems, but it's no longer as brain-dead simple as building a monolithic application. Testing is ironically easier and more challenging simultaneously. So it's easier because you can test these smaller services in isolation, but then you have a problem of verifying that they all work together. And the good news is that there are patterns that you can use to reliably test services in isolation so that you can be reasonably confident that when you deploy them into production, it all works as expected. There's sort of this kind of full end-to-end testing is sort of de-emphasized, even though that sort of sounds scary. But if you think about it, right, like Uber, I mean, they've got 2,000 services. Netflix have, probably 1,000 by now. It's not like you as a developer could easily provision all 2,000 services to do a full end-to-end test of the system, right? Or at least if you did, it would be really difficult and slow and brittle. And then deployment is more complicated because you've got all of these moving parts now. So whereas before you had the application and you just ran multiple copies of it behind a load balancer, effectively in a microservice architecture, you've got 10 applications or 100 applications or even 1,000 smaller applications, each one of which is going to have multiple instances at runtime, and all of these need to be managed and monitored, and so it's just sort of complicated. The good news is that there are things like Kubernetes, right? Or some other Docker orchestration framework, or PaaSes like Cloud Foundry or OpenShift that automate deployment. And it was sort of the stuff I was doing with Cloud Foundry kind of got me interested into the microservice architecture, which is kind of how I ended up talking to you about this today. So yeah, so it's like this complexity, but in reality, the monolithic your monolithic application is complex, and it is only going to get more complex, and there aren't ways to address that complexity. So, you've got a giant monolithic big ball of mud. It's just going to get worse and worse and worse, right? But, having said that, there's a whole bunch of different, a whole bunch of questions like, is it really a good fit for my problem or my application? Is it actually a good fit for my organization? Are we fully committed to doing automated testing? Are we fully committed to doing automated provisioning of environments? Are we fully committed to sort of embracing DevOps and Agile and being able to define our requirements in small, individually implementable and deployable pieces? Because some people I talk to, it's like, yeah, we want to do microservices. Well, but then at the same time, they can only deploy once a month on midnight on a Saturday, right? Which is almost like buying a Ferrari and then having it towed around by a horse, right? It's just, there's kind of a mismatch between your organizational processes and what you're really meant to be doing. So yeah, and then okay, if you do all of that, there's still like a gazillion issues that you then have to address once you've gone down the microservice architecture. Don't worry, you're not meant to look at that. So whether it makes sense is sort of, it kind of depends, right? So in order to help you kind of work your way through this, decide whether it's a good fit, and also if the microservice architecture is a good fit, how to resolve all of the various design issues that you're going to have to confront. I've created this pattern language for solving that. So if you go to microservices.io, you will see that. So just to recap, right? So a pattern, which is quite an old idea, popularized by the Gang of Four book, which is a set of object-oriented design patterns. But patterns are much more general than that, right? So they're a reusable solution to a problem that occurs in a particular context. And the reason they're useful is because the structure of a pattern encourages objectivity. So if you were to write up, kind of describe a particular solution or a technology in pattern form, you have to give it a name. You got to describe the context, the situation within which you're trying to solve the problem. Got to describe the problem. You got to describe the forces or the issues that you kind of have to consider and attempt to resolve. So like in the case of the microservice architecture, the context is, well, we're building a big application. The forces are developers need to deliver quickly, right, among other things. So, and then once the solution is structure your application as a set of services. And then, that's pretty good so far. But then what's really useful about the pattern format is this section called the resulting context, where not only do you describe the benefits of the solution, which is usually when we're talking about our favorite technology, it's just, yeah, it's got all these benefits, right? You also have to describe the drawbacks. So you're forced to describe the technology or the approach in a much more objective fashion. And then, so drawbacks microservice architecture is that it's way more complex, among other things. And then you also have to describe the issues that you need to resolve. So like in the case of the microservice architecture, you got issues around, well, I need to do inter-process communication. I need to do service discovery. I need to do things around observability and monitoring. So it's sort of like those were all of the issues that I had on that slide. And so there's a lot of different issues. And then once you've solved one problem, this is a recursive process, right? So there's just finer and finer grained issues that you have to address. And then the other part of the pattern that's super useful is you have to describe the alternative solutions. So in the case of the microservice architecture, when you write that up as a pattern, you will say the alternative is the monolithic architecture. So forces you to actually describe competing patterns. And then the other part of the related pattern section that is super useful is you have to list the patterns that solve the issues that this pattern introduces. So it's sort of like, yeah, you're going to, okay, so here's the microservice architecture pattern, and here's the gazillion other patterns that you now have to apply in order to solve the problems that you've just created for yourself. So basically, this format leads to just these patterns forming a web of related patterns. Either patterns are alternatives to one another, or one pattern creates a need to apply other patterns, this sort of predecessor-successor relationship. So this is the pattern language. And as I said, if you go to microservices.io, there is a version there that you can read. But kind of just talking about it briefly, there's the core patterns, monolithic architecture, microservice architecture. And then if you decide to use the microservice architecture, then everything else on the right are patterns that you then have to consider using to address various design issues, testing and operational issues that that arise because of the microservice architecture. So there are patterns around decomposition. Like, how do I identify a set of services that is meaningful? There are patterns around distributed data management. If I break my system up into services, each service has its own data, how do I maintain data consistency? So there's actually the Saga pattern for that. How do I do querying? Well, there's this API composition and CQRS patterns for that. And then all the various other patterns are sort of more, to me, what I've described so far are the kind of the essence of the microservice architecture. The other ones are sort of these more technical, more generic concerns, like how do I deploy all of this? You know, we're sort of deployment technology is evolving, and plus the needs of the microservice architecture mean that you've got quite sophisticated deployment needs. So it's like, do I package my services up as VMs? Do I package them up as containers? Or do I use cloud functions like AWS Lambda, for example? You know, those are competing solutions that have various trade-offs. And then there's a whole set of inter-process communication-related patterns, like, am I going to use messaging or RPC or REST? How does one service discover the IP address of another service in order to make an HTTP request to it, for instance? So there's discovery patterns. And then the other significant group are the observability patterns. So, you know, a request comes into your services, it bounces around, it could potentially bounce around amongst, you know, 10 different services. How on earth do you troubleshoot it, right? So there are patterns there, such as log aggregation, distributed tracing, and so on, that enable you to figure out what the heck is going on inside your system. And there are many, many more. And this is kind of work in progress. Every so often, I add new patterns to it. Anyway, so pretty much at the end, so to summarize, right, you know, the goal of architecture is to satisfy non-functional requirements. You know, in the case of the microservice architecture, that's really all about maintainability, testability, and deployability, because those determine your ability to deliver software. If you're building a small application, yeah, monolithic architecture is just fine. It's not an anti-pattern. But for a complex application, there's a pretty good chance that you should look at the microservice architecture. And then this pattern language can help guide your decision making, both in terms of choosing which architecture makes sense, but also, if you decide to use the microservice architecture, addressing all of the various design decisions that you then have to make. So that's pretty much my talk. You know, you find my contact info, email, Twitter, and one of my websites. So thank you for listening, and I hope that you found this useful.